Hey guys, welcome to Outback Workshop, and today I'm going to show you how to predict the stock market prices using a neural network in the form of a LSTM, which stands for long short-term memory. This is going to be used to predict the closing stock price of Tesla stocks using the last 90 days of their closing values. Alright, so let's jump right into it. So I'm using a Jupyter IDE here. Now if you guys don't have this, you just have to install Anaconda. And there's a pretty easy sort of tutorial to do that, but if you guys need a hand with that, just let me know. I can make a video. So first off, we'll need to import the libraries. So for this, you're going to need mass. You need pandas data reader. Now, this one doesn't actually come pre-installed with Jupyter on Anaconda, so you'll have to you actually have to install that one using pip install. So just open your Anaconda prompt. There should be like a little command prompt once you've downloaded it, and just type in pip install pandas data reader. And once you do that, it'll set it back up. You'll just have to restart your IDE once you've done this as well. But actually, before you guys do that, there's probably some more here that you might need to download, but we'll just go through them. So you also need NumPy. You need pandas. sklearn, I believe, does automatically come pre-installed with this. But we're only going to use the min-max scaler. And later we're going to use that to scale our values between 0 and 1, but we'll cover that at a later point. So you need Keras. Now this one you'll also have to install using pip as well. So you can do that one similar method, pip install, and it's just Keras, and that should install like sequential and things that are just like smaller objects inside the Keras library. Now we need Keras layers. Now if you don't do this next install, you will get an error, but it's not super easy to notice because it's actually not in the name of it. But in this line here, you actually need to install what's called TensorFlow, and that's essentially what allows you to run these different LSTM models. So I'll write that here as well. It's just like that. And I think lastly, we'll need a matplot in order to actually graph our output so we can visually see, visualize our actual results. And I'm going to use a certain style for that, which I like to use. It's called 538. Yeah, so let's run that. Should just take a little moment. Anyone not familiar with Jupyter, you get that little asterisk until the 1 or whatever part of the code line you're actually running will come up. Now, from there, so data reader, the pandas data reader actually allows us to pull information straight from the actual finance page, which in this case we're going to use Yahoo. If not, you can import a CSV using pd.csvread. But for this one, I'm going to use this just because it's a lot easier. Yes, and as I mentioned before, we're doing this for Tesla stocks. So we use the web data reader from pandas data reader. Now in this bit here, you got to put the actual name. So if you go to the actual Yahoo Finance, you can actually see it, but for Tesla, it's TSLA. And data source, set that equal to Yahoo, and we'll start the date at, we'll do 7 years worth of data, so we'll start at 2012, the 1st, and we'll just start from the 3rd, why not? and we'll end it 7 years later, so 2019, 12th, and the 3rd. Cool. So we'll run that. That's all good. So we'll show the data, so just to see exactly what we've got in. So for that, we just go type in df, or if you're on a like a PyCharm IDE, you can type in print brackets and df inside of that. That's fun. Cool. So as you can see, we're getting the high price, the low price, the open, the close, the volume, and the adjacent close. Now we're going to be using this data to try and predict the closing price here. So we'll have a column to compare our values against, which is good. Alrighty. So also you can see the amount of data that comes in if you use the if you use the shape function. So we'll obtain the rows and columns. So that is just the data frame dot shape. So as you can see, we've got 6 columns information, which 1, 2, 3, 4, 5, 6, and we're getting 1993 rows of data coming in. So, and that's over the 7-year period. So that seems a bit right. Now let's visualize, as I mentioned before, we're using matplotlib. Let's visualize the actual data that we're getting in. So we'll do that over the past 7 years. Now for that, we use PLT because that's what we set matplotlib as. So dot figure, fig size equals, I'm going to set this to 16:8. Now I typically use this size just because when you don't, it's usually quite small and it's quite hard to read. So if we do it that way, we should be okay. The next one is the title. So we'll just say closing price history of Tesla for the past 7 years. I'll comment this as I go, guys. So after this, I'll put it up on my GitHub, or if you like, I can, if you send me deets, I can email it to you, and you can have a copy of it. Now what we're doing here is we're actually implementing, we're actually implementing the actual close price column as the data. Yep, cool. From here, we'll just set a X label. So the font size is 18 for that title. And then we'll also set the Y. So it's called close price. Cool. And we'll also set that to font size of 18 as well. Sweet. Let's put this here. Sweet, so let's give this a run. That's fine. It's just saying that import future version. Yeah, so yeah, they're just updating the version of pandas, so that's okay. Cool. Okay, guys. So as you can see here, Tesla's stock prices were quite small from the years 2012 to 2013, and then they take a drastic sort of jump. They again jump here around 2017. I believe my project I actually did recently, this is because this is when the Model S came out and it was quite popular, so it sold quite a few. And then they've sort of been relatively sort of stable for the last 4 years. Yeah, cool. Alrighty, so now we have that. Let's actually create the new data frame for that closed column data. So we use def.filter to filter out that data. So close. Now we need to convert this data frame into a NumPy array. So put the data frame to NumPy array, and we'll just set a new data set. So we'll make a new variable here, and we'll set that equal to data.values. Cool. And now we need to get the number of rows to train the model on. So as you guys saw before, there's 1993 rows. Now we'll train this on, I think 80%. So we'll train on 80%, and then we'll actually test the predictions on 20% of the data. So that should be okay. So we'll set this as training data length. So 0.8, 80%. And to test this, to test that this actually shows the amount of rows that we're testing the data on, we'll just print it. Cool. So as you can see, we're training on 1595 rows, and then subtract that from here, and that's how many we're actually going to test the data set on, do the predictions for. Now we need to, as I mentioned earlier in the video, we need to scale the data now, and we're doing that between 0 and 1. So from that import that we did, this one here, min-max scaler, from sklearn, we're going to use that just to make our life a bit easier. So set that. And we'll set that to 0 and 1. Now we'll fit this to our data set. Fit this. So what we've done is we've applied the min-max scaler between 0 and 1. We've set this as a variable scaler, and now we're going to make a new variable called scaled data, and then we're going to fit that scaler using fit transform to our data set. Yep, and my bad. Yep, and we'll print that. Yep, cool. So as you can see, all the values now are between 0 and 1, which is what we want. It just makes what it allows it to do by scaling it is it allows, when you're training it, for it to converge quicker, and it requires a lot less processing speed. So it's pretty handy to run it like that. You can run it without having it scaled if you want, but it'll just take you a lot longer, and it won't converge nearly as quickly. So you have to run it for a longer data set over a longer time period, which is a bit of a pain. Alright guys, so now we'll create the training data set. And in this section we'll also create the scaled data set. So we've got trained data equals the scaled data 0 to training data length. Now here we need to split the data into X train and Y train data sets. So X train, set that to to an array, empty array. Cool. Now in here, guys, this is where we actually do the range. So we're doing 90 days. Cool. So xtrain. So doing the append here. I take 90. Cool. Let's run that. Yeah, that's all good. So now, guys, we need to convert the X train and the Y train to NumPy arrays. So take X train, Y train, and yeah, just there's a comma between those. So it's equal to NumPy array X train and NumPy array Y train. That's it for that section. Now next we'll need to reshape the data. I'll show you guys the reason for this. But basically the LSTM neural network that we're going to use to do these predictions expects the data to come in as 3D, which, as you can see, I'll run it below. So use the X-train shape. As you can see, it's only coming in 2D at the moment. So we'll reshape that. And there's also another NumPy function to do that. So we'll do X-train equals NumPy dot reshape X-train dot shape cool. X-train shape. Run that, and as you see now we're getting it in 3 dimensions, which is what we want, so that's good. Okay guys, so now we're going to actually build the LSTM model. So for this, we'll equal the model to sequential, which is that library that we installed before as part of TensorFlow. Now LSTM over 50, and that's just the amount of nodes. So guys, you can leave that at the same value. That won't affect anything you're doing, so that should be fine. Input shape equals X-train dot shape. LSTM setting it to 50 again. Now the return sequences, guys, that just means essentially, so it sort of just stops it after we do the 50 nodes, because we don't want to just keep on, adding in the same data. So that's effectively what that does. Cool, so we'll run that. I've done something wrong here. Ah. Sorry, my bad. I spelled sequential. Cool. There we go. Now we actually need to compile the model. So model.compile Cool. Let's run that. So that's compiled it. So now we'll actually do the training of the model, guys. So in order to do that, we just need to do model fit. Now we've got the X train, need the Y train, and batch size we'll set to 1, and we'll set the epochs to 1 as well. Cool. So let's run that. Now, yes, this just take about 20 odd seconds. So this is only for 90 days, so 3 months worth of data, and it's only taking the closing price each day, so it's only really doing 1 set of data per day. One thing that I'm trying to apply this for is for 5-minute data, so it actually takes about 12 to 20 hours to train. So yeah, if you start doing for bigger data, just make sure you have a dedicated GPU and a machine with a decent amount of RAM, and you should be okay. Sweet. So it took, yeah, about 30 seconds. So that's good. So now that that's trained, we'll create the testing data set. So this is the 20% of data which is left over, since we usually have 80% to train. So we'll create a new array, training scaled values. And that is from the index that was left over from, so it was 19.13, and let's take the 405 there. Cool. Okay, guys. So create our new testing data set. And we got it in that remaining 20%. So we'll do test underscore data equals scaled data training data length, and we'll take the 90 for the 90 days. Yep. And now we need to create the data sets for X test and XY. Sweet. So we'll set X test just equal to that. Y test. And this is equal to the training data length. Now we just need to append those values. So we'll do I take 90 for the 90 days. Cool. Yep, so that's all good. Now we need to convert the data to a NumPy array again. Yep. Okay, so that's all good. And this data again is going to be in 2D, so we need to reshape that to be in 3D. So test dot shape. Sweet. So we'll run that. That's all good. So now we get the model's predicted price values. So we'll set a new variable for predictions. And that equals model predict X test. scalar inverse transform. Yep. And to compare it, we'll get the root mean squared error as well. And that, as most of you probably know, that stands for RMSE. Cool. So take the square root using that's from the NumPy array. Sweet, and then we'll print that value. Sorry. There we go. Cool. So 0.48. It's pretty good. It can be better, but that's okay. To see this now, we'll plot the data now to actually see what we're pulling from the root mean squared error, so we can sort of see how well the data correlates. So here we're just going to set the predictions. Now we actually visualize this data. So here I'm just going to do a few configurations just for the actual plot. So 16:8, as I mentioned in the previous graph, it tends to be a good size. We'll set the title for it just to be called LSTM model, and that will set the X label. We'll set to date, and we'll change the font size to be equal to 18, so it's not too small. Here we'll do the Y label, set that, we'll just call it the closing price, and we'll also set that as a font size of 18. Now we'll actually plot the data, which was the close, and we'll also plot, so this is going to be a comparison, because the training was the training data that we did, and the valid is the actual predictions, so that way we can compare the two. Yep, so that's done, and we'll also put in a legend just so we can exactly see the difference between the values. So for training value, and that's for the actual value, and predictions, and that's what the LSTM model that we implemented actually predicted. And we'll put this in the top right. Oh, actually, we'll do lower right, because as you saw from that previous graph, it does actually go off into the top right axis direction. So to make sure that it doesn't overlay that, we'll just put that in the bottom right, and we'll show. Cool. Alright guys, so as you can see, the blue here is the train, which we saw in that original image output. The red here is what values actually were, and the yellow is our predictions. So it was actually really accurate, as you can see from here. It did struggle to pick up some of these the highest points of the outliers from here, the highest peaks, but overall I'm pretty happy with that. It does a pretty good job estimating that. And yeah, so if we want to actually output those values, in case you guys were trying to implement this to help you with your stock price predictions or anything, you can, that's part of valid now, so you can see here and where a value, typically it's only about 1 to 4 in between there, which is pretty good. So if you guys want to actually output that, yeah, just take it from here. There is also a convert to CSV file application which you can run. But yeah, so I'll put this up on the GitHub, guys. I'm currently trying to work on setting up one. There's a group of us here at the uni, because we're, as you've probably seen from other videos, if you have seen them, we're also working on a Robotus OP3. So we're trying to make a sort of a shared environment where everyone can sort of, you know, get access to that to try and help development. Yeah. Well, thanks for watching, guys. I hope this helped you. If there's any other questions or any other videos you would like made, please post them in the comments below. And like and subscribe would be awesome, guys. Sweet. All right. Well, enjoy your day. I'll see you guys next time.